Hello guys, my name is Ahmad Zakwan bin Ahmad Zawi. I'm from class DKF4B and my sex number is 11DKN19F1067. So today I'm going to do JETS experiment, which is simulation. Okay, let's start. Okay, so procedure for the experiment is as follows. Click or tap on the start button to start the experiment. Number 2, the water shall start flowing through the pipe. The level in the jet shall start rising. Number 3, the water will go through the nozzle and hit the flat plate and displace the scale. Number 4, try to change the flow speed by using control flow speed glider. Bringing the glider to the left will slow down the water flow, whereas bringing it to the right will speed it up. Okay, number 5, the control flow speed glider is dynamic and can be changed midway when the water is filling up too. Alright, so number 6, click or tap on the reset button to restart the experiment afresh, i.e. with empty apparatus. Okay, to read about the procedure of the experiment, click here. Okay, let's click. Alright, so objective: to verify the momentum equation experimentally through impact of jet experiment. Apparatus required: impact of jet apparatus, weight and stopwatch. Okay. So procedure. Number 1 is note down the relevant dimension as area of collecting tank and diameter of nozzle. Number 2, when jet is not running, note down the position of upper disc plate. So number 3, admit water supply to the nozzle. Number 4, as the jet strike the disc move upward. Now place the weight to bring back the upper disc to its original position. So number 5, at this position, find out the discharge and note down the weight placed above the disc. Number 6, the procedure is repeated for different values of flow rate by reducing the water supply in steps. Okay, so let's start. Okay, so for simulation, okay, so you guys can see the water is up here. Then so that's all. Thank you. Okay guys, so for objective, the objective of this experiment number 1 is to investigate jet force impacting against stationary deflectors. Number 2 is to compare the experimental result with the theoretically calculated values. So the next one is theory. Okay, impact of jet apparatus enable experiments to be carried out on the reaction force produced on vanes when a jet of water impacts onto the vane. The study of these reaction forces is an essential step in the subject of mechanics of fluids, which can be applied to hydraulic machinery such as the Pelton wheel and the impulse turbine. So the next slide is water jet surface. So for flat plate, number 1 is for flat plate, and number 2 is for hemisphere, number 3 is for slope, and number 4 is for cone. Okay, apparatus required. So number 1 is impact of jet apparatus, number 2 is weight, and number 3 is stopwatch. Okay, so now procedure. Okay, number 1 is note down the relevant dimensions as area of collecting tank and diameter of nozzle. Okay, number 2 is when jet isn't running, note down the position of upper disc or plate. Okay, number 3, admit water supply to the nozzle. Number 4, as the jet strike the disc move upward. Now place the weight to bring back the upper disc to its original position. Okay, number 5 is at this position, find out the discharge and note down the weights placed above the disc. And number 6 is the procedure is repeated for different values of flow rate by reducing the water supply in steps. Okay, so the next slide is the data. Number 1 is measured values for flat plate. So number 2 is measured values for hemisphere, 180 degrees deflection, and number 3 is measured values for cone, 135 degrees deflection. Okay, so dekat tepi ni ada note dia, cara kira. So this is the result. One is flat plate result and number 2 is hemisphere result, 180 degree deflection. Okay, so the next result is number 3. It is cone, 135 degree deflection. Okay, this is my analysis. So this is my calculation for water jet force. Okay, so this is my discussion. Okay, so for the next discussion is my graph. Okay, so plate is blue, hemisphere is black, and cone is red. Okay, and then plot the graph of force measured F vs calculated force FTH, and for different deflectors discuss your graph results. So for the next discussion is, the higher the estimate forces are for flat plate, the heavier the loading placed on top of the device. Because of the short time it takes for the water jet to reach the plate, the plate will get closer to the water jet as the load increases, resulting in greater estimated forces. The more force placed on the device, the more fluctuating it will be in the hemisphere. Okay, in the case of a cone, the larger the weight placed on top of the apparatus, the higher the predicted force. But when the loading is very heavy, the calculated force decline. This is because the larger loading leads the cone to approach the water jet more closely, reducing the time it takes for the water jet to reach the plate and resulting in higher estimated forces. Okay, however, when the cone is too close to the water jet, the computed forces diminish as the water bounces back towards the water jet, delaying the calculated force. So, the conclusion. Okay, to sum up, we may say that the findings we obtained for the theoretical and experimental values are both incorrect. This is owing to the fact that the discrepancy between the theoretical and experimental value is 43.33%, which is a significant difference. The three primary explanations for the disparity are the equipment, lack of accuracy, assumptions and restrictions made during the experiment, and human error. So this is my references. Okay, so now the next is safety procedure. So we should to follow the rules in the lab, which is if we don't want bad things happen, we should to follow. Like if you are going to lab, must wear shoes, not slippers, and yeah. So this is my personal protection equipment. So yeah, this is the outfit that you need to wear when you entering the lab. Like you should wearing a shoes, and then seluar panjang, baju bengkel, and then a mask, and then actually you need to use spectacles, right? In the lab, because it halang abuk daripada masuk mata. Okay guys, that's all, and thank you so much for watching. Okay, bye.